Good morning, folks. So we talked about rigid body motion. We focused on rotation about the fixed axis, and then we talked about general planar motion. We used Newton's second law and third law, or generally speaking, Newton's laws to analyze the motion of a specific rigid body or a group of rigid bodies. Now, what we're going to do in this class is that we're going to start looking into work and energy and using principle of work and energy to analyze the motion of a rigid body. Right? We talked about energy method before when we were talking about the motion of particles. Right? We said when we are dealing with when we are using Newton's second law, we typically find a relationship between force and acceleration. But in energy method, the main focus is to find the relationship between the force and the velocity of the object, in this case, a rigid body. Right? Now, let's see how does this work for a rigid body. So I'm not going to go into details about the whole idea of energy methods. You can take a look at what we talked about back then when we were talking about particles. The general idea is the same. Right? There are minor changes. There are some changes when we are dealing with a rigid body, and we're gonna see what those changes are. But let's start with definitions. Right? Let's start with basics now. Principle of work and energy. And let's see what is the equivalent of that in rigid body dynamics and when we're dealing with rigid bodies as opposed to when we were analyzing the motions of particles. Right? So, all right, principle. Oops. For some reason I can't write principle. Principle, there you go, of work and energy. Now, let's define or explain this principle for a single rigid body and a system of rigid bodies separately. Essentially, they are the same. When we are dealing with one rigid body, we specifically say that we only care about external force and couples, right? We say the work done by those external forces and couples when a rigid body moves from point 1 to point 2 pretty much is equal to the change in the kinetic energy of that rigid body. Now, keep in mind that we're talking about rigid bodies. Now, if we don't have a rigid body, right? We define rigid body when we start talking about rigid bodies and like a few weeks ago. Now, if we're not dealing with a rigid body, let's say it's a flexible body, right, as opposed to a rigid body, actually work can be done by internal forces. We're not going to talk about it, just you know. That's the difference between a rigid body and flexible body analysis when it comes to work and energy method. But for a rigid body, pretty straightforward. We'll say the work, let me just put it this way, for a rigid body, the work done, let's put it this way, by external forces and couples as let's say as a rigid body, trying to follow the definition on the textbook, as a rigid body moves from, this pen is not cooperating today, moves from position 1 position 1 to position 2, let's say equals a change in the total kinetic energy, equals the change in the total kinetic energy. Kinetic energy of the body. Right? So this is just for one rigid body. And as I said before, if it's not a rigid body, then we care also about the internal forces. We care about internal forces as well. Now, for a system of rigid bodies, it's pretty much the same. But when we have a system of rigid bodies, right, we also care about the internal forces. Internal forces interacting between different rigid bodies within that system. Now, this is a little different. You see, internal forces also come into play. So, let me also put that for a system of rigid bodies, system of rigid bodies, let's put it this way. The work is very similar, but it includes internal forces. The work done by external internal forces this time, by external and internal, hopefully it gets better, and internal forces and couples, obviously. You will see as one of the differences between energy methods, applying energy methods to rigid bodies as applying it to particles, because now we also have to deal with couples. Internal force and couples as a system of rigid body, as a system of rigid bodies move, let's put it this way, between two, let's say two positions also. Two positions. There you go. Equals the change in the total kinetic energy. In the total kinetic energy of, well, let's just put it of the system, of this system. Of the system. Now, general equation is the same, right? General form of the equation, well, the work done going from point 1 to point 2 is equal to change in the kinetic energy. like whether it's just one rigid body or a system of rigid bodies. Now, I'm going to look into first kinetic energies and or the kinetic energy and see if see what is the difference between a rigid body and a particle when we're dealing with kinetic energy, and we'll look into the work done by forces. Now we'll see that it's not just about F or force in as a vector. It's also about couples or moment applied to the rigid body. Since we have a rigid body, we also deal with couples now, and they can also do work. So we'll see. We'll look at these two, well, both sides of this equation, and see how can we actually form this for a rigid body or for a system of rigid bodies.